Welcome back. Today we've got a repeat guest, our first one ever. It's going to be amazing. We brought back Dr. Sarah Powell from UT Austin because we alluded in the last episode that she has a lot of knowledge about the equal side. So we're thrilled to be bringing her back today. How are you doing, Sarah?
Hey, I'm really great. How are you all today?
Doing good, doing good. It's starting to warm up in Arizona, and I'm kind of
Nice.
sad about it, actually.
Oh, yeah, yeah. Well, that means that winter is gone or whatever winter
Yes,
you might have there.
yes, exactly.
Well, I'm
Yes.
really excited to be back and to with both of you and very excited to talk about the equal sign. So this should be fun.
Yes, absolutely. So, just a reminder that Dr. Powell has researched a lot of really interesting things, testing interventions with students that have math learning difficulties, a special emphasis on peer tutoring and word problem solving, writing in mathematics and symbols, which we'll talk a little bit about the equal sign today. And so, we're just going to dive right in. This is going to be a great conversation because when I was thinking about the questions, I'm like, well, what is there really to know? And there is
Yeah,
so much to know after
there
I sat and
is.
reflected about it.
Oddly, yes.
Yes,
Yeah. Yeah.
yes. So I have to know like why the equal sign? Like what an interesting thing. You did your whole dissertation about it.
I did. Yeah.
Tell us what is so special about this equal side and how did you pick
Yeah.
it?
Yeah. How did I get in there? So when I was in graduate school, I worked with Dr. Lynn Fuchs, who was a professor working on word problem solving. And we were in the midst of developing a program, which is now pretty well known, called Pirate Math, where
Yeah.
students were setting up and solving word problems. And my colleague Pamela, who I wrote that program with, we were using equations to represent word problems. So
Mm,
you might write, an equation like 2 plus 3 equals blank to represent a word problem, or you might write an equation like 2 plus blank equals 5, or blank plus 3 equals 5. Like wherever the unknown information is in that word problem, you can use an equation to represent the concept or the schema of the word problem. And so I was working on developing a lot of those lessons with Pamela and Lynn and, testing them out in schools and then going back and redoing them and making them better to really come up with the final Pirate Math project, which a lot of people are pretty familiar with today. So that was all about word problem solving, but using equations within word problems. Then in my PhD program, I took a class in a different department with a professor whose name is Dr. Bethany Riddle Johnson. And she is a psychologist who does a lot of work related to cognition and specifically cognition in mathematics. And so
mm,
I took a class with her, and she actually asked us to read one of the articles that she had written probably 10 years prior to that time,
wow.
to give us an idea of some of the research that she's interested in. And that article was all about how students misinterpret the equal sign. Now, Bethany, probably wasn't interested in the equal sign from maybe an instructional point of view at that time. I think she was more interested in how quickly can we change students' thinking when they have an incorrect conception of something, how quickly can we change that to a correct conception of something? But I read this article in my class, and then in my research job, I was using equations to represent word problems. And so I wondered, because I had never thought about it at that time. The students write the equation, they solve the equation to solve the word problem. And I started to think like, well, do students actually understand that the equal sign means balance instead of do something? And so I was just on the cusp of the time where I had to figure out my dissertation project. And I remember going into Lynn Fuchs' office and being really nervous to propose this idea to her. And I was like, I have this idea that as we use these equations, students might misinterpret the equal sign. And I wonder if that in turn influences their word problem performance. And Lynn was like, okay, I think, that's a good idea. She also told me not all dissertation projects have significant findings. But she's like, I think it's worthy of investigation. And so, like, any PhD advisor should always allow people to investigate within reason what they want to investigate. And I'm so
Right.
glad that she did. And so then we were running this word problem intervention. And so I recruited some additional students where they did the word problem intervention pirate math plus this
Mm,
focus on the equal sign. sign. And we just ran it for 15 sessions, but even at the end of that 15 sessions, we did see that when students learned about the equal sign as a balance between two sides of the equation, and they did a lot of equal sign practice, that did in fact improve their equation solving, which
Mm,
then turned around and improved their word problem performance. So that was back in 2009, 2010 when I was working on that. And then my first really large research grant that I ever received from the US Department of Ed was focused on taking that and running it at scale. So we then did a 45 session intervention on now the program, which we call Pirate Math Equation Quest. The Equation Quest part of that is all about the equal sign and solving equations with information in different unknowns in different positions, and really helping students understand the equal sign as this relational symbol instead of as that operational symbol. So it was one paper that I read and a project that I was working on at the same time. And I just made a connection between those two. And then since then, I've read, I would say probably 75 to 80% of the articles that have been published on the equal sign, which surprisingly, there are a lot. And I've met a lot of researchers like Bethany and like Nicole
mhm,
McNeil and Eric Knuth and Martha Alibali, who've done a lot of research in this area. And then I've done some research on my own, and we continue to see that students still interpret the equal sign often as do something, so an operational understanding of the equal sign,
mm.
instead of the equal sign as a balance. So here I am. There's kind of a family joke. I like, I don't know if I should, I'll tell you, but
Yes, tell us.
yeah, so it's not like a funny joke, but my sister one time, um, was like, "Oh, Sarah's in such and such state." And my mom's like, "Is she talking about the equal sign again?" And it's like, yeah, here I am almost 20 years later,
Yeah,
still talking about the equal sign. So there we go. Yeah.
I love that.
Yeah.
So just for the folks listening, maybe they're not really sure what that looks like. So
Yeah.
what are some misconceptions that students are seeing, or what does it look like so that educators and parents kind of can identify it?
Yeah. So many students without instruction interpret the equal sign as what we call operational. So operational means they have to do something. And usually students will see the equal sign and they'll just add, subtract, multiply, or divide. And many times that works out. So if it's 2 plus 3 equals blank, and I just do something, I add those numbers together, I'll likely answer that 5 and I'll answer that equation correctly. But what happens is when equations aren't these like very typical equations. So maybe it's 2 plus blank equals 5. A lot
Hmm.
of students will write 7 on that blank space because they see the 2, they see the 5, they see the plus sign, and the equal sign has always indicated, oh, I just have to do something. And so they end up writing an equation that looks like 2 plus 7 equals 5, and that is not correct.
Right.
So that's like this operational understanding of the equal sign. Like they just have to do something, they have to operate on the numbers. In reality, students need to interpret the equal sign as relational. So we have these two sides of the equal sign. And the example that I provided before, that's one side is 2 plus 3, the other side
Hmm.
is 5. And so 2 plus 3 has to equal or balance or be the same as 5. And so there's a relation between the two sides of the equation. And we need to make sure that those two sides of the equation are the same. And there's I don't know if we're going to get into it today, but there's so many really cool connections to how students compare numbers with the equal sign. So actually, the equal sign and the inequality symbols, so the greater than
Hmm.
and less than symbols, are directly related because really you have two parallel lines for the equal sign, and then if you are thinking about greater than, you pinch it on one side. You take those two lines and pinch on one side. If you're thinking less than, you take those two lines and pinch on the other side. And so then we could say, like, oh, this side is less than that side, or this side is greater than that side, or this side is the same as that side. So we really need students to think about the equal sign as relational, particularly as they move through the grades. There's a lot of students in middle school who still think about the equal sign as
Hmm.
operational. There's quite a few studies that still show that. And there's actually some studies that show that even college kids will often think the equal sign means I have to do something rather than it's this balance between the two sides of the equation. And so as the equations that students work on get it more complex. So now let's say students are doing something like 2 plus blank equals 6 plus 7, then we really need to make sure that students understand that there's these two sides of the equation have to balance instead of we just do something like adding them all or multiplying them all.
Yeah, absolutely. And I yesterday before the show started, we talked about you posted on X that Hand to Mind has a new math manipulator out that looks like a scale, and
Oh, it's
we'll
so
try to
cool.
put
Yeah.
this into the post in post edit so you can see it.
Yeah.
But what was so cool is that when you push down on one side of the scale, just like you were saying, it would turn into a greater than or a less than
Yep.
sign.
Yeah.
And that just was such a powerful visual. It just really made that dual coding of like what's happening in front of you
Exactly.
really
Yeah.
make a lot of sense. I thought
Yeah,
that was fantastic.
I love that tool from Hand to Mine. And I've talked to some of the developers that worked on that, and they said it was fairly difficult to develop because they really had to get the weighting correct. So you can
Mhm.
add cubes to one side and cubes the other side. So if there's 9 cubes on both sides, you will see an equal sign. But if one side has fewer cubes than the other, then you'll see a less than symbol. Yeah, like the lines move, and it's very cute
Oh,
and very cool. Yeah.
it's
And
so
there's a
cool.
lot of other good manipulatives. I'm sure you all are use them regularly, but we use balance scales in a lot of our
Yeah.
intervention work, and those
Yeah.
work really well. But I do love it's like a little frog creature that where they can see the equal sign, the greater than symbol, and the less than symbol, and how those relate to one another.
Yeah, it's fantastic.
It's very cool. Yeah.
So when you're introducing the equal sign and the concept of equal, what's some accurate mathematical language we should be using?
Yeah. So we have an assessment that we give students about the equal sign. And what the first question is, what does the equal sign mean to you? And so many kids say equals. And we're like, okay, well, yeah. And then we'll be like, what does equals mean? And then it's like crickets, right? And so really we want students to think, we use a lot of the terminology around the same.
Mhm.
And so when we read equations with students, we'll say 2 plus 5 equals 7, or 2 plus 5 is the same as 7. And really importantly, we would also want to expose students to equations they don't always see so that they also think like, oh, 7 is the same as 5 plus 2. So we don't always want the equal sign to be, and what I think about is like the second to last position in an equation.
Mhm.
And so we use a lot of the language of the same as, and we use that in like facts, like, yeah, 2 plus 5 equals 7, or 2 plus 5 is the same as 7. You could also say 25 plus 25 is the same as 50. And so replacing this idea of equals, which just is an ambiguous term that students don't have a meaning that's connected to that term, that then the same. Most students understand that this side can be the same as that side.
Yeah, absolutely. And you alluded to this a little bit, but what kind of equation type should we be using to help
Yeah.
students develop that understanding?
Yeah, great. So there's different types of equations out there. The most often we're thinking about what I term and what other people have termed standard equations. So that is an equation with
Mhm.
one operator symbol. So an operator symbol might be like the plus sign, minus sign, multiplication symbol, or division symbol. An equal sign, because it is an equation. So an equation has to have an equal sign in it. An expression does not have an equal sign. And an inequality would be the greater or less than symbol. So much math language that we can get into here.
Yeah,
But
yeah.
anyway, with standard equations, there would be, I call them like three positions for numbers. So a standard equation would be 2 plus 5 is the same as 7, or 14 times 2 is the same as 28, right? So it's like number, operator symbol, number, equal sign, number. And sometimes that number might be a blank space, but really you've got three positions where a number can go. So those are standard equations, and students see those primarily at least like 80 to 90% of the time when they're working on math, particularly in the elementary grades and even into the middle school grades. But then there's non-standard equations, which really get at, let's see, how do I think about non-standard equations? Non-standard equations really help us think about the equal sign in a more in-depth way. So I think they think about problem solving and they
Hmm.
also get into algebraic reasoning. So,
Hmm.
non-standard equations can fall into a few different categories. First, there are identity statements. These are statements where it's like 3 equals 3 or 14 equals 14. A lot of
Yes.
times, these are used alongside manipulatives or drawings just to show that two sides of an equation are the same.
Hmm.
Students don't have to work a lot with identity statements, but they are out there. So, that's one thing. Then we have what I consider like three position non-standard equations. So would be where the equal sign is usually in the second place in the equation. So that would be like second 7 equals 5 plus 2. Or we could read that as 7 is the same as 5 plus 2. And so their students don't see those that much, but of all the non-standard equations, they see those the most often. And they see
Hmm.
standard equations almost all the time, but if they do see non-standard equations, it's often just kind of like flipped like that. Then
Right.
there's these really cool equations that really get at to thinking about the equal sign in a relational way. And those are what I consider four position non-standard equations. So this is often where we'll have two numbers on each side of the equal sign with some type of operator symbol. So just very
Hmm.
simplistically, that might be like 2 plus 3 is the same as 4 plus 1. All right.
Hmm.
And
Hmm.
so I've got position two, four positions. Now, many of our assessments when we're getting into equal sign understanding are like those four position non-standard equations, but you could also have five position or six position. But you can just keep adding numbers all day long. But the idea there is that students really have to think about balance if the equation is 2 plus blank is the same as 4 plus 1. Right.
Hmm.
And
Hmm.
a lot of kids would answer that as 7, and that's not true. They have to think about, well, if this side equals 5, what do I have to add to that side to make those two sides the same? So those are all different types of non-standard equations. And all of those non-standard equations really require a pretty good understanding of the equal sign as relational.
Yeah, I really like that. And you talked about the identity statements. And Heather and I, when we were working on our book that's about adding and subtracting within 10,
Yeah.
we realized the starting point was right there, like helping them understand. And so I wanted Heather to share a little bit more about what she kind of put together and what she noticed as we've
Yeah.
been teaching these students with dyslexia, dyscalculia, because it
Yeah.
that moment was so important and we could not skip it.
Yeah, that's cool. What did you find out, Heather?
Well, in our book, we realized if we just started with addition and subtraction facts, a lot of the kids who weren't learning those facts, it's because they didn't really have an understanding yet of equals.
Mm,
Our book had to actually just start with like an equation board with the two
yeah.
and the concept of equal and unequal with no
Hmm.
operators. And I think that surprises people. It sounds like, oh, rare kids here and there don't understand that identity, but it's really not true. Like the bulk of our kids really needed to start with that,
Yeah.
unlock everything else. So it goes
Yeah.
along really well with what you were saying that you found in your research. So I'm glad that matches.
Yeah, no, yeah, it's like they need to have that practice of these three bears is the same
Mhm.
as these three bears over on the other side of the equal sign. Yeah. And so much of that, so much of I think what kids think about the equal sign, they haven't necessarily been taught, although I've seen quite a few books and other resources that do say like, oh, the equal sign means answer. It's like, no, 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 that's not what the equal sign means, but it's just through so many practice opportunities. And if the first 100 or 200 times you see the equal sign, most of the time students just added and wrote an answer. We almost condition students into thinking about the equal sign as operational instead
Mhm.
of doing activities like the ones you're talking about, where students have to think about, oh, if I have 3 here, how many do I need to put on the other side so that those sides are the same? Yeah, that's a
Yeah.
great, yeah, it's great that you did that. That's cool.
Yeah, I think it's great that we've talked about some of the manipulatives, like using centimeter cubes or Unix
Yeah.
cubes, counting bears. I'm curious, like, what does it look like as we're developing it into having students draw and then get a little more abstract with it?
Yeah. Yeah. So in our current intervention where we're working with fourth grade, we do work around the equal sign because we're also doing stuff with word problem solving. And so we now know how important interpreting the equal sign within equations is for improving word problem performance. So we do start with balance scales and centimeter cubes, but we could also use other manipulatives that are out there. There's also some really nice balance scales that are number lines, and you hang these little weights from the numbers out,
Mhm.
like coming out from zero. So there you can say, like, hang two weights over here, like 4 and 3, and then that's the
Right.
same as 7. So those are really, really nice. But then we pretty quickly in our intervention work transition to doing a lot with drawings. So we have found just how we have these pages, and it is very, very simple. It has an equal sign in the middle and two large rectangles on each side of our one rectangle on each side of the equal sign. And so if we are faced with an equation, let's say it's like 4 plus blank equals 7. Well, on one side, we draw 4 of something, whether that's 4 just sticks or circles. On the other side, we draw 7 of something, maybe 7 squares. And then we ask, okay, how many more do you have to draw on this side so that the sides are the same? And the student might draw one more circle and we'll say, okay, now you have 5. Is 5 the same as 7? No. Okay, draw another. Okay. 6 the same as 7? No. They're not the same. Okay, let's draw another one. Oh, great. 7 is the same as 7. So now we can say, oh, you drew 3 circles. So 4 plus 3 is the same as 7. And so having that ability to do that drawing, whether it's with pencil or with marker, or if you're doing it with a stylus, then students can do that in many ways. And we do that also with multiplication and division and subtraction. So it's like, oh, how many do I have to put in each group so that the sides are the same? So we do a
Mm,
lot of drawing there, but then always tying that drawing to the abstract form of the equation. So if I'm doing drawing with, 4 circles and 7 squares, and I have to draw in some to figure out what 4 plus blank equals 7, students also see the equation written out with numbers and symbols. So 4 plus 3 equals 7, and then they'd read that 4 plus 3 is the same as 7. So we're always trying to tie those multiple representations together. And the same thing, if students are using the manipulatives with the balance scale, the abstract equation is always present as well.
yeah. And I think it's great to point out that, like, verbalizing these things and having the student echo back what they're
Yeah.
saying
Yeah,
really helps build that internal dialogue when they
for
are
sure.
in a setting where they have to be more quiet, right?
Yeah,
I
exactly. And
love that you're
go
modeling
ahead.
that.
Yeah.
Go,
And
yeah.
there's one more thing that we have also gotten into, and that is the equal line. So many times once we get into computation and we're
Mhm,
not presenting, with facts, many facts are presented horizontally. So you're got a
mhm,
lot of use of the equal sign. But when we get into computation, a lot of our math is presented vertically just because it's easier to work within place values with that. And so maybe if I'm thinking like 25 plus 25, I have 25 and then I have 25 below that, and then I have this equal line. And we've talked with students, we do this in our intervention, that the equal line also means the same as. So
mhm.
here, not only am I going to side, but top of the equal line to the bottom of the equal line, 25 plus 25 is the same as 50, right? So
Right.
and I don't think many people really get into the equal line because it's usually more of like a procedural thing. But I do think it's
Right.
important to talk to students about what does that actually mean, and that also means that 50 is the same as 25 plus 25. So we need to make sure that students understand that symbol as well, because that ends up being kind of the de facto equal sign for many
Mhm.
students at some point in their math career.
I love that. That's such a great point. Making a mental note, Heather. We're going to update some of our stuff too. I'm also thinking back to kind of the beginning of the conversation. You mentioned something about that understanding how the equal sign works can give students like this slight advantage over word problem
Yeah, yeah.
solving. Talk about that a little bit more.
Yeah, it doesn't solve all your word problems, all
No.
right? So, I mean, we're talking about a somewhat minor player in the world of word problem solving. I mean, in word problem solving, it's really important that students have an attack strategy. It's really important to focus on the concepts, or what we call those schemas of the word problems. But many times, students are going to use either a graphic organizer or an equation to represent the information from the word problem. And most often in the earlier grades, we use graphic organizers, but even then we pretty quickly transition to equations. But starting around grade 3 or 4, you, like, even as an adult, would probably write an equation that represents what's going on in the word problem to be able to solve the word problem. And so
Mhm.
what we have found, we did a study at grade 3 a few years ago, where we found out we ran 2 interventions on word problem solving, and they were identical except for one thing. Half of those word problem students participated in this activity we call Equation Quest. So they had 5 minutes every day where they talked about the equal sign as relational, learned the equal sign as the same as, did all the stuff we're talking about, used balance scales, used
Mhm.
drawings, solved a lot of different equations. And then every time they saw the equal sign, they said the same as. And then the other word problem intervention had just a 5 minute filler activity where they didn't learn about the equal sign in that way. They didn't do those activities. They didn't learn about the equal sign as the same as, and so on. But students in both conditions were using equations to represent word problems and solve those word problems.
Mhm.
And what we learned is that the students who got the Pirate Math Equation Quest, first of all, at post test, they showed improved understanding of the equal sign. So, not a surprise. We taught
Mhm.
them about the equal sign.
Mhm.
This is like a whole thing called sequential mediation, which is very nerdy, but very cool. That understanding of the equal sign improved their equation solving. So those kids that participated in Pirate Math Equation Quest were better at solving equations than the kids who did not get that practice. Again,
Mm.
not totally surprising because if you practice things, you usually get better at it.
Mhm.
But the thing that then we saw is that then when their equation solving was better, it actually led to an improved word problem performance above and beyond the kids who just did the word problem intervention. Now, the kids who did the word problem intervention really did exceptionally well at post test above kids who didn't do the intervention at all. But the kids who did Pyromath Equation Quest had a slight advantage
Mhm.
over the kids who just did Pirate Math alone. So it shows that there's some benefit to understanding the equal sign as relational and working with all of these different types of equations. If you don't do it in your math instruction, is it the worst thing ever? I'd say no, it's not the worst thing ever. Again, focus on attack strategies, focus on schemas first, but it's a nuanced part of your word problem instruction, and kids really like it. And it's also it's helping them for the long term. So we actually saw with those grade 3 students, when we visited those kids again in grade 4, only the Pirate Math Equation Quest students continued to show significantly
Wow.
higher word problem performance than the Pirate Math alone kids. And again, it was not like the biggest difference ever, but it was there. But I think it's like would be really interesting to think about, well, what are those kids now doing in 6th grade and 7th grade, knowing that they had
Mhm.
this pretty intensive practice on the equal sign? Does that help them with pre-algebra or algebra coursework later on down the line? So, yes.
I would
So
imagine that it
I
would.
would hope so. Yeah, I would hope so.
Yeah.
Yeah.
Yeah, that's really cool.
Yeah.
Okay, we could just keep going and going and going, but
Well, yes, we
yes,
could, but
yes,
yeah,
we'll have to
it
have
is
you
only
back
one math
again.
symbol. So you've got
Yes,
to do a podcast for all the other math symbols
all
at
the
another
others.
time. Yeah.
There's so much nerdy hidden meaning in these symbols, and I think it's
Oh,
fun
I
to
love
teach kids
thinking
these
about the
things.
symbols of mathematics. Yeah.
Yeah, it's really fun. Okay, do you have a silly joke for us?
Well, I have a equal sign joke for you.
Oh, I
Yeah.
love it.
So,
Let's hear it.
okay, I looked this one up. All right, I did not create this equal sign joke on my own. The joke is, why was the equal sign so humble?
Oh, why?
Because it knew it was no greater or less than anyone else. Bum bum.
That that is the best joke.
Yes, yeah,
I
yeah.
love that.
Well, thank you, Adrienne, for humoring me on the equal sign joke. Yes.
It was such a joy to have you. We'll have you back again someday in the
Yeah, we'll
future.
talk
And
about whatever you want to talk about next. Yeah.
yeah, that would
So,
be amazing. All
yeah,
right. Thanks for coming, Sarah.
it was nice to chat with you. So, thanks so much.